As we go on to the last topic of Chapter 7, Section 8, we're introducing something very important, the complex numbers. So far in our textbook, we've only been dealing with real numbers, numbers that are on the number line. Well, here we're going to introduce numbers that are not on the number line. And in a sense, a new big umbrella for all of our math numbers, and that is the complex numbers. Now, what are we talking about? And by the way, let me mention that as we do these types of things, and you think you need more information, you could read your textbook or look at the video in which I use the textbook pages and I review everything that's in the textbook. So that's much more thorough, much more inclusive of everything. Here, this is just an outline, a mini lecture. Okay. Well, we have said throughout that anytime we have the square root of a -4, there are no two numbers that will give us a -4. So this is under the radical sign. So this is not a real number. But if we work with this a little bit and introduce something, we're saying we're going to introduce what is called the square root of -1. And we're going to call this letter I, lowercase letter I. Now, when they developed this years ago, they call this an imaginary number. Now, it's not really imaginary, but that name has stuck to it. It's a number we use in mathematics. And we will define the square root of -1 as I. And if we square this, we get a -1 equals I squared. So I squared will be developed throughout this section as a -1. What is I squared? I squared is a -1. And whenever we get I squared throughout our calculations here, we will convert that to a -1. Now, another important thing is complex numbers are made up of a real number part and an imaginary part using this. And when we write it, we write complex numbers in the form of A, which is your real number part, plus BI, where I is the imaginary part and B is a real number. But in this combination, it's referred to as the complex numbers. This is the standard form of the complex number. And later they're going to tell you to use that right down here. Okay, so let's get started. And again, take good notes. This will be your Bible in a sense, your record of what we've been doing. And there are a couple of special rules that we need to note, and we will note them as we go along. So we want to write this in terms of I. So often what we do is we say the square root of -1, that's your I, times the square root of 3. So we convert this to I, the square root of 3. Now, by convenience, we often put the I in front of something like this. its real official way to write it would be the square root of 3i, but there is the danger of having this confused by extending that radical sign over the I. So we often write the I in front, even though it should be written this way. So here we're going to again do the square root of -1 times the square root of 81. Well, the square root of 81 is 9, and the square root of -1 is I. So we get from this 9i. Now here this is a little tricky because there's a negative sign. So that goes out there. We take out the square root of -1, which is I, and then we divide this into the square root of 16 times the square root of 3. Remember, we're looking for the perfect square factor. So what is the square root of 16? Well, this is a 4, and this is an I, and our negative sign is still out there, and we have the square root of 3. So ideally, you would put this I at the end here, but they usually write it as 4i and a negative 4i, the square root of 3, for letter C. Now, the nice part of the I value is that when we're working with it, it's treated just as if it were a variable of some type, a letter. So in adding or subtracting, in here we're adding, we're just going to combine like terms. 5 plus 6 is 11. A positive 4i and a positive 1i is a positive 5i. So that's just straightforward. Now in subtracting here, what we have to do, and again, take the time to do it, is change these signs. We have to reverse it because of the negative. This will become a -6. This will become a positive 15i. Now remember, it's worth the time to write it out. Just mentally doing it and then forgetting to change one of the signs, not a good idea. So this becomes a -3 and a plus 2i and a plus 15i give me a plus 17i. Okay? All right, we'll raise it up a little bit. Now, when we multiply, here's where the rule changes just a little bit, and you need to be careful of it. Now, you would say negative times negative would be a positive. When you're doing imaginary complex numbers, you can't do it that way. This will become, you do this one. This is a 3i, and this is a 7i. Now that's important, as you'll see in just a moment, because we now get 21. 3 times 7 is 21, I squared. But what did we say I squared was equal to? -1. So we never, I repeat, we never leave I squared as a letter, a variable, imaginary number in any calculation. We always convert the I squared to a -1. So this is 21 times -1. This is a -21. Now notice, if you multiplied the negative times the negative in our real number working, that would have become a positive. But in imaginary numbers, you're not allowed to do it that way. You have to convert it this way, and the I squared changes the sign from a positive to a negative. So let's do this one. This is going to be the square root of 4 times the square root of 2. So this is going to be 2i, the square root of 2. We have to use some of our other things. And this is going to be times I, the square root of 11. Again, we're following the same technique here. So what happens? Well, 2i times I is 2i squared, and 2 times 11 is the square root of 22. But notice you have an I squared there. Can't leave it that way. What is that I squared? It's a negative 1. So this answer is going to be negative 2, the square root of 22. Now, if it's like this already, it's not under radical signs, we can just say negative 5 times 4 is a negative 20. I times I is I squared. And what did we say I squared was? A negative 1. So this is going to equal a positive 20. In letter D, we're just going to distribute. This is going to be a positive 12i, just multiplying these. And this is going to be a negative 42i squared. And we said I squared is a negative 1. So this becomes 42 plus 12i. And that is written in this standard form over here. A plus bi. This is the standard form. Theoretically, they could count it wrong if you wrote it the other way. But I noticed down below, this is how they're writing the answer. They're writing it the other way. So they're not following their own directive, which I guess we have a little wiggle room here. This is the way it should be written. Now, when we FOIL, and we'll do that little by little, this is going to be 12. Now, when I do my inners, I get a 30i minus 2i gives me a positive 28i. I'm doing this part mentally, my inners and outers. And then when I do my last, I get a negative 5i squared. Now, what did we say I squared was? A negative 1. So this is going to become a positive 5, and I'll take away my I squared. Now, what do I have? I have a 12 and a 5, which gives me a 17 plus 28i. And that is my answer to this one. Okay? As we go on to item 4, they want us to find conjugates. And if you recall from earlier lessons, we introduced this word a long time ago. Conjugates were terms that were the same terms, but one was plus and one is minus. And when we FOIL those, they gave us the difference of perfect squares. The middle terms canceled out. So this is a tool from our toolbox that we use. And what they're asking us here is, what is the conjugate? And these are called complex conjugates because they're part of the complex number system. So what would be the conjugate of this? And you can say, well, it's just the same terms, but in the middle, the opposite sign. So this is a -4. Now this will be a plus 5i. That would be the conjugate. Now here, they're giving the conjugate as a -10i. And where that is, in fact, the conjugate, all we really need is a -i here, as you'll see when we do this down there. Okay, so now what they want us to do is to multiply conjugates. Well, keep in mind, if they are conjugates, there is no middle term. So you don't have to multiply the inners and the outers. They're going to cancel out. So this is just the first, which is a 4, and the last, which is a -81i squared. But what have we always said that I squared equals? A -1. So this is a -1. So this then becomes a positive as we take away the I squared. And we converted it to a -1 times a negative made it a positive. So the results of this is going to be 85. Now we're going to do that for letter D because they want us to divide. And remember how we used to rationalize the denominator? We're sort of like getting rid of the imaginary number in the denominator by multiplying it by its conjugate, the conjugate of the denominator, which is 5 plus 4i. 5 plus 4i. Remember, this is a 1 in this form that will, in a sense, change the denominator from being imaginary to a real number. And let me write it out over here. I'll do this bottom first. So 5 times 5 is 25 minus 16 I squared. But I squared is a -1. So this is going to end up being a positive 16. And 16 plus 25 is a 41. So let's put that down here. And again, this was 25 minus 16i squared, which was a -1, times a negative made this a positive 16, and 25 gives me my 41. Now we're going to FOIL the top. And I'll do it up here. Negative 3 times 5 is a negative 15. Now for my outers, I'm going to write it down here. I get a negative 12i, a negative 3 times 4i, a negative 12i. Now this is going to be a 40i. 5i times 8, 40i. So this becomes then a 28i. So for my middle term, I get a positive 28i. Now for my last term, I get a 8i times 4i is a positive 32i squared. Multiplying this times this. But I squared is a negative 1. So what am I going to get here? I have a positive 32 times negative 1 is a negative 32. This becomes a negative 32. A negative 32 and a negative 15 give me a negative 47. There we go. Now, I then have just my positive 28i. Now, as we look at that, and if you double check all the work, and if you check down below, it looks like that, but not quite like that. We got all the right parts. The thing is, this is not in the form of A plus BI. In order to be in that form, it has to be a negative 47 over 41 plus 28i over 41. Now that is in the standard form of the complex number. If you write it like this, MATLAB is probably not going to count it correct. You have to write it in standard form. This is the real number. That's what A is. And then this is the complex number. In fact, you see I put that I up over there. It probably should go right over there. But that would be all right, and I'm assuming MATLAB would count it that way. But there's your correct form for it. Wow, lots of stuff going on here. All right, let's go on, because we're now going to do this one. Oh, gotta get a new one here. There we go. And I'll go back to red. Now, our conjugate of this, we said, was a negative 4i. But a little shortcut here is just use the negative I. You don't have to use that 4. Because by doing that, then you're going to have to cancel later. So this is the better way to do it. You could do it the other way, but then you'll have to simplify. So we'll just do it this way. So what does my denominator become here? Well, it's going to be a negative 4i squared. And what did we say I squared was? A negative 1. So a negative 1 times a negative 4 gives you a positive 4. So that's what I'm going to do. Make this a positive 4. Now, this numerator then becomes a negative 4i, and this becomes a negative 7 I squared. What did we say I squared was? Negative 1. So this is going to become a positive 7 here. Now, again, putting that into MATLAB, they're going to count that wrong because what you needed was to put it in standard form. So that's going to be 7 over 4 minus 4I over 4. But notice what you should do here. Cancel that out. So your final answer here is going to be 7 over 4 minus I. And notice that's in standard form. A plus BI. Okay, our last little section that we're going to do here, and I guess I can raise it up a little bit, we get to see the answers, is powers of I. Well, for this, I'm going to give you a little lesson. We said that I equals I. And we said that I squared equals a negative 1. Well, what does I to the third equal? Well, it's the product of these two, so it's going to be negative I. A negative 1 times I is negative I, because this is like I times I to the second equals I to the third. So I to the first is I to the second is negative 1. Negative 1 times I is negative I. And what is I to the fourth? Is I squared times I squared. And what is I squared? Negative 1. Negative 1 times negative 1 is a positive 1. Now, when you go to I to the fifth, can you see it's I to the fourth times I? I to the fourth times I is I to the fifth. But we said I to the fourth is 1. 1 times I would be I. And by the way, that pattern continues. I to the sixth is I to the fourth times I to the second, which is going to be a negative 1. I to the seventh is going to be I to the fourth times I to the third, which is negative I. And then I to the eighth is I to the fourth, which is a 1, times I to the fourth, which is a 1, which is a 1. So this pattern continues by just knowing this first column. What you need to do if you get a number like, let's say, I to the ninth, you're going to convert that into I to the fourth times I. Well, this is a 1, this is a 1, and this is I. So I to the ninth equals I, because you are teasing this apart into I to the fourths. So when we go to I to the 26th, and they're saying simplify that, what you are looking for is I to the fourth, which is a 1, raised to the 6th power, which is still just a 1, and this is I to the 24th, and then what do you have left? I to the second, right? This is a 1 to the 6 is 1. That's I to the 24th times I to the second. What is I to the second? We said I to the second is -1. And that's what letter A is for 5. -1. All right, now we have I to the 71st. Well, if we had I to the 4th, which is a 1, what would be the closest thing to that? Well, I to the 17th, which is 68, I to the 68 times I to the 3rd. And by the way, I did some calculation of this. I just divided this by 4, and I got 17 3/4. So the 3/4 is I to the 3rd. So this is going to be -I. And this one's easy. I to the 41st, put it up here. I to the 41st is going to be I to the 40th times I. And any multiple of 4 where you have I to an exponent that is a multiple of 4, this is actually I to the 4th, which is 1, raised to the 10th power, times I. This is going to be just plain I. And that's what they have. So, in a quick review then, and again, you can read the textbook, goes over. I think I do a better job than they do, but that's okay. I is I. I to the second is -1. I to the third is a -I. I to the fourth is 1. Now, what you're looking for is how many I to the fourths do you have in any power of I. Those are just going to end up being a 1. So it would be like the remainder after you have multiples of 4, and then it's going to be somewhere between the first, the second, and the third. So it'll be these 3, because if it's an even multiple of 4, the value of simplifying I to some power is just going to be 1. I think these are fun, and hopefully you understand what's going on here. And we've run 33 minutes, but this was a big topic, and probably you'll have one of your exams.